Hello everyone, welcome to Tech Buddy. I'm Salih. In today's video, we are going to be talking about some code optimization. I'm saying some code optimization, but we will be seeing a lot. We are going to have a function that does masking on an email address. For example, any given email address, let's say salihjantekin@gmail.com. And we are going to be calling this function with two additional parameters. First, the visible character. So if it is 2, let's say, then the first 2 character will be visible and the rest will be masked by using the third parameter as a char. So in this case, if this is given and this will be the output. So there's a function, so mask email and v1, let's say, we are going to be having 7 different versions and we will be benchmarking those as well. We are going to be calling this function and the output will be this part. In Basically, we are going to have different parts of this function, this string. For example, the visible parts and the masking part, as well as the domain part. But we don't want the domain part get masked. This is going to be the answer. So if I give you this task, you would probably be doing the basic, and the first idea could come to mind is basically, let's say v1. Not that v1. That v1. Sorry, that 0 actually. I'm not going to be benchmarking this v0. It's because this is the version that everyone knows. But our purpose is right now is to optimize this, make it faster, and also make it use less memory, right? So it's going to be time and memory efficient. The first thing comes to mind. I know, okay, there's an at character in it. I can split it into 2 parts. So I would have this part, this part and this part. And the first part and the second part is an array as a string value. I can get the visible part only by using the substring from the first part and then make additional string that the length of is basically however characters that I'm going to be masking. And this is the new string. And the rest is basically by adding, concatenating and the add symbol and as well as the second part. So this is going to give me, this is going to be performing, by the way, well, at least well, but it is going to be giving the the output for you. So if this is the given string and you will be getting this one. So this works perfectly. But not only it should work, but also it should be efficient. So this is your goal. This is your task today. I'm not going to be benchmarking this, but on every edition, on every version 1 to 7 or something, every edition, every version will improve the performance. There will be some improvements cases we are going to be talking about in detail, but you're going to see how slightly changes make it more efficient. So this was the version 0 that, as I said, I'm not going to be benchmarking this. But if we go to v1, what I would see is, okay, let's validate the string first. If it is an email or not. There could be many other ways, like using the regex or regex, however you like. This could be other parts as well, but the regex, so the regular expression, is not going to be part of this validation for this video, but you are likely to go. And even source generated regex you can use. But in this video, I'm just going to be checking if it contains at. If it contains at, that will be a valid email address. All right. So the first thing, the first improvement, first optimization we do is basically the validation. If email string, given string, is not an email, or even if it is empty, just exit early, right? We don't need to do the split part or something. And then we can do the split part again. And then additional condition over here. So I know the email part before the domain address. So for example, in this case, it is Salih Jantekin. So let me just make it a bit bigger though and get rid of this. So the email address, let's say s@gmail.com, but the visible characters is 2. In that part, actually, I'm not going to be able to do any masking on this email address. So I'm going to be returning this one. So this is another optimization. This is another concern that I considered. And then, okay, the rest is the same basically. So I am concatenating any string for visible characters. Basically, I am reading everything from the local part, from the first part. and another loop for the visible for the masking part actually. So I'm basically combining those into a string, and then last concatenate and return it first. Okay, this has some optimizations as well, like early exits and validations as well. So in V2, we are going to be doing something. It's because if you know me before, so I was talking about spans, and people know how much I like spans. Is because it is one of the best ways that we can manage our memory and we can use it efficiently. So, and also it's because of the nature of the string in C sharp and nature of the string as it is immutable. When we try to change it, like that one, for example, every time we are concatenating anything, we are basically changing it. It's going to cause us lots of memory. So if you know me well, so you basically spot the first problem over here, concatenating lots of things. So you might say, okay, what is the version 2? You might say, okay, we can use any string builder for that one, right? It is going to be referencing only one string, one allocated part, I can say, not a string. But let's check what we have. Validations over here, it is the same. And again, splitting parts and having the first and local and domain part. And again, early exit check. And in this case, now I'm appending everything I have into a string builder by, again, getting the substring, so the visible part, and then the making new string, which is going to allocate a memory. And also for the chars, the masked part. And again, I'm basically concatenating the thing. And so this is the version 2. This is a bit performant than this one, version 1. I'm going to have version 2. It's because I'm going to make a slightly changes over here. So in that case, I have created my string builder without any capacity or anything. But in this case, I'm going to provide a capacity. So I know what the string build is going to hold, right? It is going to hold the whole email address with visible, mask, and the domain part, but the length doesn't change. So if I provide a capacity to string builder, it knows that how long my string in that string builder is going to be, so that it's going to arrange the array behind the scene. So it is going to be slightly better performant than our V2. We are going to be seeing it probably in our benchmark test, right? So this is the same, but the one slight difference is providing the capacity. Okay, let's switch to version 3. So version 3 will be, so I'm just going to split my versions before and after 3, okay? 3 is included for the before part though. And again, I'm just checking if it is null or not, and then looking for an at index. Basically, what I was doing here is it checks if it contains, right? And also return null. But in here, I am checking index of and finding at index. It's because over here, I'm checking, so I'm basically looping through to find that string, but also I'm splitting it. So split is also going to look for that part. And so it is again looping through into a string, but I am doing it over here only once to find it. If I can't find it, or if it is again visible count check and early exits, so this is going to be more efficient than that. And the rest is basically the same: local part, domain part, providing the capacity, and appending it, and then appending it, and appending it, and again appending it, appending everything. But it was over here, it was not appending, so a new create string over here, and then to string, new allocation, again concatenated, again new allocation, and also new allocation. So this V2 has more allocation than the third one. It's because now I'm appending everything into my string builder and returning it to as a string only once. So the version 3 is going to be better than version 2 and version 2 too. Let's switch to version 4. Now we are going to be seeing some different things with mostly spans. As you again know me, I like talking about span. Again, the validation part. But over here, now I'm going to call a create function of a string class. And it is going to give me the opportunity that I can manage this, what this string is going to be like, by saying, okay, I am providing a length. So how long this string should be, I'm telling it. So I'm going to allocate a string for that amount of length. Okay, let's say 20 character of length, I'm going to be saying. And also it is going to give me an action over here. It's because if you hover the mouse, it says span action over here by providing me a char and string. Basically, it gives me the opportunity to fill that span up by creating no memory allocation for that part at least. So I have span and I have the full email address. It is passing it to me back. So if I can use. Now I am going to fill that span by allocating no memory. So what I'm going to do is, okay, I know email, use it as span, but for only the visible character. So I'm basically getting 2 characters of it as a string and copying it to my span. So I'm basically filling up the span by getting first 2 characters of this email address. So basically it is referencing it to, again, so first of, so after this line, basically in my span, the first 2 characters will be pointing out the same email address that I had already allocated. So it's creating no extra allocation, right? So this span, I'm basically filling up this spans, and in this line, only first 2 characters. And then I have to create another string over here. I have to create this one. So this is the masked part of it. New string, but again, as a span, again, I am allocating 1, but using that one as a span and also copying its value to, again, to span my span over here. So basically, visible part, I'm getting this emails, the mask part, the visible part actually, mask it and put it into my span again without with zero allocation apart from this one. And again, for the domain part, again, I'm getting the email from @index, so basically finding the domain part and again copying it to my span. So what I have done over here is basically create a string of that length, provides me a span. I fill up that span by only creating an extra memory allocation over here. And then it will be basically my length of new allocation. It's going to give me a string. I will just use the span to fill it up, and then it's going to fill that, it's going to convert that span to a string. So this is so far the most efficient conversion or masking an email. It's because if you check the others, there are a bunch of things over here, basically using string builder. Again, use string builder itself is going to allocate some memory, but again, over here, basically I'm saying, and over here, it's basically managing an array again on the allocated part. So obviously the v3 is going to be using more memory than v4. It's because over here we only created a string that length of this one and extra for this one. So okay, this is the fourth. So first 3 will be different than the fourth, the last 3. In last 3 we are going to be using some spans, right? So this is version 4. Let's switch it to version 4.2. So here I'm just going to say, okay, I am not creating additional allocation here. If you remember, I was basically doing this one, creates another allocation. But for v4.2, I'm not going to create additional allocation for that part. But what I'm going to do is having a for loop here, right? And into a span. So however character it is, this is the how much it has. And then basically with a for condition, if condition over here, basically I'm setting spans I value. So each value I'm basically looping through and deciding if it is going to be visible or masked. I'm not going to be creating additional allocation here. However, you are basically gonna see a difference between version 2 and version 4 and version 4 version 2. One will be faster and the other one will be using less memory allocation. You're probably gonna see it and I will explain it later. And now switching it to V5. So V5 is going to be something amazing. And probably this is going to be faster so far. So it's going to be faster than V4. Again, this part is the validation and checks, blah, blah. And now I am using string concat. So again, it is the same almost by having this one. So instead of string create, I am now using string concat by again passing the same parameters, visible part, masked part, as well as the last part. But again, this is accepting span. This is accepting span. So string concat is allowing me to use span, read-only span as well. So this is going to be the only string I allocated. So it seems like the same. Over here, basically, I am using the copy to part, copy to part while creating a string. But there is another difference over here, which is, so the version 4 and version 4.2 is going to be using more memory than version 5, probably, I assume. That's because creating an action over here, so it is going to give you an action by allocating some memory for it, and within that action you are basically setting your span up. So this will be the memory part, so memory, additional memory part, I can say. So that's the reason, creating an action over here to give you the opportunity to fill that span up. And this v4 is going to be using more memory than v5. It's because now I'm concatenating basically three values, which only one, using creating memory allocation, I can say, for the masked part. So far, the v5 is going to be the fastest and the most memory efficient, I can say. String concat accept spans. And let's switch to 6. 6 is different. So this has unsafe key. It is a C# key, specific C# key. To be able to use the unsafe key, you should basically allow your application by passing this allow unsafe blocks true parameter. After this is true, you can now use the unsafe. But unsafe means mostly in C# that I'm going to use pointers. So C# is a high level programming language, and it doesn't allow you, by default, it doesn't allow you to use pointers. It's because if you don't know what you're doing with these pointers, that your application might fail, crash, basically, without any control, without throwing any exception. All the exception will be unhandled and it will be failing, it will be crashing on the operating level system. But if you know what you do with the pointers, then you are allowed to use unsafe. So what I mean is by that, so again, the validation parts. Now I'm going to create a string, empty string. I'm going to call it result. So this is going to be the whole email address allocation on somewhere in the memory. And instead of filling up that string, or instead of using some another span and blah 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 blahs to fill that string up, now I'm going to go its pointer over here. I'm going to call it p result, pointer result, as well as this email. So p email, I will be using two different pointers. It's because email as a string has an address in the memory. I don't know, but this will be it. This will be pointing up this address. And this is the result that I just created, has also another address. What I'm going to do is go to memory, copy the value from that, not copy it back, but let's say copy the value from one address, put it to on another address. So only memory allocation will be this one. It's because I'm now creating any additional string over here. Basically, I was creating the mask part, right? And also I was creating mask this one. So the action over here I was creating. But this will not be creating additional. Basically, I'm basically getting this pointer address and pointing only the memory address, not the actual value though. What I will be doing is basically, again, having a three part actually. The first, again, for the visible part, and the second one is basically the mask part, and then finally copy the rest of the email. Basically, I am going through within this pointer address instead of having the actual value. And this is going not going to be the fastest, but also this is going to be the most memory efficient. This will be fast, but this also is going to be fast. So V5 and V6 is going to be almost the same as in time, but this is going to be the most memory efficient. So you're going to see the difference. So the unsafe and pointers. Um, email mask email v7 is something that is neither efficient nor fast, but it is something that you might know. If you're going to deal with unsafe and pointers, you might also want to use Marshall class in C#. It basically gives you the opportunity to do manual things on memory, and as well as whatever you are having as an object, and manage what is holding it. Let's say if you have a list, you can basically access its array behind the scene and do something on it. So Marshall is for sometimes, in many cases, in most cases, memory efficient. But if you again know what you do, I'm going to do something similar that I have done already in version 6. But again, now I am allocating my own memory by calling string to an H global uni. Basically, I'm creating pointers for that email address as well as the result. Again, result is the new string. So basically, this is also getting a pointer the way that to get the pointer. But again, you will be seeing the difference. Now I am using Marshall write int 16, write in 16, write in 16 function, as well as mark read int 16. Basically, it is reading the value now. It is reading the value from the memory, bring it to over here, and also writing it to into the where the pointer shows. So this is going to be taking some time, right? So it is reading it from there. So it is not happening on the memory side. It is happening on my program side, my application side. And now as I have the P result over here, so I didn't have to for that one. I didn't have to convert anything. So I had my result over here, pointer result, but I didn't have to convert it to a string. But over here, and now I am basically converting it to string instead of having the result over here or result. I can return that result as well. But again, this is going to create any other allocation. And also, as I just allocated my own memory over here in the final log, I need to free them. I need to deallocate them to be using the memory more efficient way. So those are the functions, those are the optimizations. So this is V7 is going to be an exclusion, but I just wanted to show you if you are going to deal with pointers over here. The another way is basically using the Marshall class, but as in this usage, Marshall class is going to create additional allocation. But now let me show you what the benchmark is. So in benchmark, I'm using .NET benchmark tool, so you can use the same. And I have emails array over here in the setup. Basically, I am generating fake email address by using bogus faker. And also I am 70% of this email address are valid email address, but the 30% are basically wrong. It's not an email address. So no, we don't need you. So in some cases, it's going to be having just randomly, it's going to be 500 words over here. You can see characters, sorry, 500 characters. So it's going to be big string. So just to see how our optimization works with even bigger values, and some basically I am creating some distortion in the email address, basically replacing thing and making it not a valid string email address, and also ordering them by generating new GUID. So in the list over here in the array, it will be randomized in the setup, and the rest is basically the same. I'm basically going through, looping through the email address and passing those into my functions, and this will be the baseline. So the first V1 or V0, it really doesn't matter. But we are going to be seeing how much the other is faster or efficient, more efficient than this one. So it's going to be giving us the opportunity. Let me run this application in release mode. Let me run it. And once it is over here, it's because it's going to take time. So now I'm basically using only 1000 email address, but it could even be more than that. And also getting the memory. But if I just wanted to use the cold start with the invocation of 2, which will be even faster, but it's probably not going to give us the actual value. So that's why I'm not using a simple job and cold start. I'm giving it time so it can do all the invocations, all the warm-ups, and show us the best result. And now let's wait for the results. Now the results are back, and let's see what we have here. So let me zoom it in a bit. Yep. Now it's better. The result says I was right. It's because the V1 is the less efficient, as you can see, in time, as well as the memory allocation. And every iteration it makes it better. So 71 and 7, basically changing one. If you remember, the change was between these two is only the string builder capacity. So it is, let's say it is the same in time, but also I can say, okay, we have some little slightly improvement on the memory allocation. So this is something, if you're using string builder, you can set the capacity accordingly. And then the version 2. So I said, okay, the first 2 is the first 3 is different than the rest. It's because it was using string builder and string concatenation or something. So you can basically see the jump between these two, as well as in the memory side. So 100, 414 and 174 only. It's 3 times faster in both, actually. So this is the version 4, and this is the version 4.2. So you can see, as I just said, okay, one is basically creating additional allocation by passing this action over there. So it is using more memory. The other one is basically using less memory, but it is faster. It is slower. The for loop, looping through in a span and settings, creating an additional condition, is basically taking more time than using this one. But so you can decide which is faster, which is more important for you. If it is faster, you can go with that one. If it is using less memory, you can go with that one. So the 5 is, as expected, it is the most efficient as in time so far, and 14 nanoseconds, and also 100 kilobytes only. But V6, as I just said, the time will be almost the same, so it is even closer. But in the memory side, on the allocation side, this is going to be actually using less memory with 60 kilobytes only. So in time, both are almost the same. But if you think that the allocation and memory management, memory allocation is more important than you, so the V6 is your friend over here, as long as you know what you do with the pointers, so with unsafe function. So if you don't know, please go with that one. In the Marshall side, we were creating double string. So it is almost, actually it is more than the twice of this one. It's because now it's creating the result, but it's also creating additional string by using the pointers. Marshall is almost the least efficient after this one, and it is neither the more efficient than the others almost. And where it sits between these two. So in memory allocation, using pointers are okay, but it's going to take time if you create more allocation by using your Marshall. So this optimization shows us how much we can go in deep. So from 1 to 7, we can go in that deep. And also, this is only 11% of this one. So if it is 1, this is the 11%. So 98%, say 89% more efficient, I can say. We can go in there, but this is the safest in this matter. This is the safest and fastest and the most efficient way you can use. If you like this video, please hit the like button. If you have any question within optimization, in terms of optimization, in terms of span or strings, you can ask your questions in the comment below. This is going to be the whole from this video. Until the next video, happy coding.